So how are we gonna estimate our population parameters? Let's talk about some basic ideas and basic terminologies. Okay, so our first term is confidence level. And confidence level is the probability alpha 1 minus alpha, often expressed as the equivalent percentage value, that is the proportion of times that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. The confidence level is also called degree of confidence or the confidence coefficient. These are alternative names. The most common confidence levels are going to be 95%. We want to be 95%. Basically, that confidence level tells you how confident we are in our estimation. So we would say we are 95% confident, then our mean or our proportion or our standard deviation is within this interval. So the most common ones are 95%, 99%, or 90%. Those are most common, but they're not the only ones. Now, notice that here in the definition, we're mentioning alpha, and alpha is, so the confidence interval is 1 minus alpha. So if we have a 95% confidence level, that means that alpha is 1 minus 95, or 0.95, 95% in decimal form, which is 0.05. For 99% confidence, we're going to have alpha that equals 0.01. And for 90% confidence, our alpha is going to be 0.1. All right, so sometimes you're going to be given the confidence level, like 99% confidence. Sometimes you're going to be given alpha, just saying at alpha equals 0.01, find the confidence interval. So automatically, you know that it's going to be a 99% confidence level. Critical value. Critical value is the number on the borderline separating the sample statistic that are likely to occur from those that are unlikely to occur, commonly denoted by Z of alpha over 2. So if we're looking for, let's say, a 95% confidence interval, what that means is that we're gonna build the interval 95% around the mean, right? So this means that we're gonna have this cutoff value here. If we have a 95% in the middle, that means that we're gonna have 5% in the ands of the distribution, right? So we're gonna have 25% in the left and 2.5%, sorry, 2.5% in the left and 2.5% in the right end. So we're going to have 0.025 on both ends. And this is alpha divided by 2. That percentage is alpha divided by 2. Remember the alpha that corresponds to 95% is 0.05 and 0.025 is alpha divided by 2 because we have to split it into 2 ands. Now the Z values are the values that cut off the bottom 2.5% in this case and the top 2.5%. All right. All right. Next, when data from a simple random sample are used to estimate a population parameter, also known as the margin of error, denoted by ME, is the maximum likely difference between the observed statistics and the true value of the population parameter. So for example, if we say that our population will have a gas price of 6.35 plus or minus, I don't know, 50 cents. So my 50 cents is the margin of error in this case. And then if I wanted to actually write it as an interval, I would write 6.35 minus 50 on one end, which will give me 5.85. And then 6.35 plus 0.5 on the other end, which will give me 6.85. All right, so margin of error. Next, let's talk about critical value denoted by Z of alpha over 2. We talked about it here. Is on the borderline separating the right tail with the area of alpha over 2 to the right, which we already mentioned. So let's see. Now, I want you to notice that here we're talking about the z-value, which refers to the standard normal distribution, right? With to remind you, a standard normal distribution has a mean of 0 and a standard deviation of 1. It's a normal distribution with those parameters. Okay, so if we're talking about the critical value, Z of alpha over 2, that corresponds to the 98% confidence level, that means that we are looking for the values that separate. So from here, alpha is 1 minus 0.98, so that's going to give us 0.02. Alpha over 2 is going to be half of it, which is 0.01. So we have 0.01 in one tail and 0.01 in another tail. So we have 100% total under the curve, right? So the critical value is the value that separates this 1% on the right. Now for this one, it will separate 99% on the right, correct? Because it's this 98% plus this 1%. So to the right of this value, we'll have 99%. So how do we find those values? We're gonna look at our StatCrunch calculator. So we're gonna go to stats calculator, select normal, mean 0, standard deviation 1. It goes to standard normal right away. So for our area to the right, remember this is our area field, or the probability field. We're going to put in 0.01, and that will give us a value. But look, it gave us the value that separates the bottom 0.01, which is fine. That's our value on the left end. So, and that value is negative 2.33 approximately. Now, if we change this sign, see, we have 99% on the right side. But if we change it to 0.01 to the right, we're gonna get a positive 2.33. So that's what we got for our critical value for 98% confidence interval. Okay, now for next question, it says find the critical value corresponding to the 99.5% confidence level. So again, if we have a confidence interval where we have a 99.5% in the middle, what do we have left? Well, first of all, alpha is 1 minus 0.995, so that's going to be 0.005. Alpha divided by 2 is going to be 0.005 divided by 2, so that's 0.0025. Okay, so it's a 0.25%, 0.25%. Okay, so we're going to have 0.0025 in the right tail and 0.0025 in the left tail. So here we're looking for the z value that has 0.0025 on the right hand side of it, and on for the value on the left hand side, the critical value on the left hand side, that's we have 0.995 plus 0.0025 on to the right of it. So that's going to be 0.9975. Okay, so again, let's open our StuckCrunch and take a look at what those values are. Okay, so here we're putting 0.0025. So that value is 2.81 approximately if we round it to 2 decimals. And can you guess what would be the value on the left side? We said that the area to the right of that value is 0.9975. And yes, it's a negative 2.81. If that's what you guessed, then you were correct. Okay, so these are our critical values, and those are the values that separate our percentage in the middle, the percentage that we ordered, right? Our accuracy value right here from the rest of the values. So this is a terminology that we need to know in connection with the confidence intervals. So that's confidence levels and the critical values that are associated with those confidence levels. And in the next videos, we're going to talk about confidence intervals for estimating mean, estimating the population proportion, and population variance.